Okay, section 1.3 is where you're going to be measuring segments, and it is talking about congruency, but it also starts where we're going to solve equations, so that's why we spent some time reviewing that part. So this first part up here is just showing you the coordinates, and it's just wanting you to realize that if you have 2 points on a line, that it can create on a number line where those coordinates would be, and that would just be those numbers representing it. It's also wanting you to realize that you can find the distance between 2 points by just subtracting it and then also taking the absolute value. So this is something that you want to make sure that you are using quite often to find the distance, but really it's just something you would do in your head. So let's take a look at the first question. It's saying, what is ST? Well, here is ST, here is S, here is T, so I would just subtract them. So I could do 8 minus negative 4, which is 12, and my answer would be 12. Okay, very simple stuff. If I went the other direction, negative 4 minus 8, remember distance is always going to be positive, so that's why you would end up doing the absolute value of negative 12 and getting positive. Alright, pause the video and try the got it question. Wants you to know what are the distances UV and SV. So UV goes from 10 to 14, so that's going to be 4. SV goes from negative 4 to 14, so that's going to give you positive 18. If you have questions on that, let me know, please. Postulate 1.6 is the segment addition postulate, and this is something that you'll continue to use even after today, so you'll want to keep it in the back of your mind, especially when we start doing proofs. Segment addition postulate says you're going to take one small segment like AB, add to it another small segment that's right next to it like BC, and that's going to obviously form the same line that you would get if you were to go from A to C. So that's all it's saying. 2 small sections equals that one big section. So down here at the bottom, it gives me a line segment, and from E to F, it's giving me this expression, F to G is this expression, and then it told me from E to G is 59. So if I was going to use the segment addition postulate, I could use it to find the measurements of EF and FG. So all I would have to do is set it up. So my segment addition postulate says take EF, add to it FG, and that would give me the big section, which is EG. So here is EF, 8x minus 14. I just substitute that in, plus FG, which is 4x plus 1, and that's going to give me my big section, which is equal to 59. Now is where we're going to solve our equations. So I'm going to combine my like terms and get 12x, combine negative 14 and 1 and get negative 13. I'm going to add 13 to 59 and get 72, and then I'm going to divide so I get 6. Now the answer, and this is where you got to pay attention in geometry, because geometry likes to have you critically think. You always need to go back to the question and make sure that you're answering it, because sometimes they ask for x, sometimes they want you to plug it back in. Here's a question they want you to plug it back in. They want the distance of EF, so I would need to plug 6 in here in order for me to solve it out. So if I plug in 6 in for x, I would get this expression. So then I could multiply 8 times 6, subtract 14 from that, and get 34. I would do the same setup for FG. I would need to plug in 6 for x and get 24, and then add 1 and get 25. Alright, I want you to pause the video and try the got it question. Okay, so here are my 2 expressions and then my total. So I would set it up JK plus KL equals the big one, JL. So in doing that, I substitute in my expressions. 4x plus 6 is JK, KL is the 7x plus 15, and then 120 was what JL is. So then I start solving. Combine my x's so I get 11x, combine my numbers and get 21. Then I'm going to subtract 21 over and get 99, and then divide and get 9. Now again, I go back and I check. They're not asking for x, so you would want to plug 9 into both of these expressions. When doing that, you should have found that JK is 42 and KL is 78. All right, on the back side, this is real simple stuff at the beginning here. It's asking me, are these segments congruent? Well, what does congruent mean? Congruent means they are equal. So make sure you know what congruent is because I'll use it over and over and over again, okay? Congruent means they are equal. So it's asking me, are these segments congruent? Well, let's see. The length of AC is from -2 to 5. So AC is 7. And then it's asking me what's BD. Well, BD is from 3 to 10, which is also 7. In order for them to be congruent, they are equal, and they are, so my answer is yes. Pause the video and try the got it question. Alright, in the got it question, it says use the diagram above and see if AB is congruent to DE. AB turns out to be 5 because it goes from -2 to 3. DE is 4, going from 10 to 14. So no, they are not congruent because they don't have equivalent distances. Last piece, midpoint. Midpoint is something we will continually use over and over again. The midpoint of a segment is a point that divides the segment into two congruent segments. Midpoint. Mid meaning middle, point meaning point. So that means I'm at the midpoint. The other thing that it gives to you is a point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect. That point, the line, ray, or segment, is called a segment bisector. So first off, B is a midpoint because it cuts it into two congruent pieces. And then segment bisector means this is the line that bisects it, so that's just the name of it. Okay, bisect, bi, two, secting, cutting it in half. All right. Using the midpoint, this is saying Q is the midpoint, so how do I find those distances? Well, think to yourself for a second. We just discussed what a midpoint was. What's a midpoint going to tell us? Well, a midpoint told me that if this is my midpoint, this section has to be congruent to this section. In putting in these tick marks, that's showing that they are congruent. So if they're congruent to each other, I would just set it up as an equation. I would put that line PQ is congruent to or equal to QR. So if that's the case, I can substitute in my expressions. So I have 6x minus 7 equaling 5x plus 1. Then I would just start solving. So I would subtract 5x, add 7, and I end up getting 8. Now, it's not asking me to find x, it's asking me to find all of these lengths. So I would have to plug all of that in. So for PQ, I would plug 8 back in there. So I get 48 minus 7, which is 41. Plug 8 back in here and get 41. And then PR is all the way across. So I could just add these two together and get 82. All right, you're going to pause the video one more time and try the midpoint on the last question. So it tells you that that U is the midpoint. So that means that TU is congruent to UV. So I can write that out if I want to. And then I can just plug in those expressions to help me solve. So then I would subtract 8x from over here, add 1 to over there, and then divide and end up with x equaling 3. Once again, not asking for x, so I would need to plug back in to find it. So I plug in 3. 3 times 8 is 24. Add on to it, I get 35. UV should be the same as that, so it's going to be 35. And then TV is going to be the double of those, so I get 70. So I'm just adding those two together. So once again, a lot of introductory stuff, but there is jam-packed in here with information that we will continue to use. Congruent, you will hear that word over and over. Midpoint, you'll hear that word over and over. Segment bisector, you'll hear that word over and over. On this side, you will use that segment addition postulate over and over. So even though there's a lot of stuff going on, I need you to closely pay attention and make sure that you know it, because I'm telling you folks, it will not go away.